All right, welcome back. Once again, this is Mr. Spinks. We are in, again, section 2.2, and we're going to start here with a very short video. This is the second video of section 2.2. This one's going to discuss the difference between elements of a set and subsets of a set. So we're still talking about sets here, but make sure you can differentiate between these two things. Starting off, here's a definition that's going to help you with this. So, an element of a set is just a member of a set, one single member of a set. But a subset is a set, so it's not just one single member, it's an actual set that may contain a single or multiple elements of the original set. So we're going to go down here at the bottom here at this example, and I'm going to tell you the original set is A, which contains 5, 10, 15, 20, 25, 30, and 35. Now you're going to look here at the bottom and see whether or not you think A, B, C, or D are elements or are subsets of this original set, or are nothing. So I'm going to give you a sec, take a look, be back in just a moment. All right, we are back. Now let's talk about A. I look at 5. 5 is not a subset. It's just a single number in this case. And I look up to the original set and say, yes, I see 5 in that original set. Therefore, 5 is an element. Again, this is how we write element of set A. My handwriting's a little rough, but at the same time, this is a simple answer going on there. That's the first one. Second one, we look, I see braces. That indicates that this is a set here, okay? So it can't be an element now because there are braces. It's indicating to me this is a set. All right, this set has 15, 25, and 30. So I want to know, is this a subset of the original set? To figure that out, I'm going to look to see, is 15 there? Yes, it is. Is 25 there? Yes, it is. Is 30 there? Yes, it is. So this set here, which contains 15, 25, and 30 has all of the actual elements that are in set A, and therefore it is a subset of set A. Simple. Moving on to the next one, I look at 40. Now 40 is a single number, it doesn't have braces, therefore it must be just an element. So I look to see if it's an element of A. But 40 is not in A, so this is nothing right here. It is not an element, it is not a subset. We'll just write nada for nothing. Whoops. Finally, last one here. Now don't be fooled here. It says 10 and you look and you go, well, that's a single element and it's in there. Therefore, it's got to be that 10 is an element of A. No, it's not in this particular case. In this particular case, since there are braces around it, we are indicating that this is a set. And we need to know if the set here that we have on D has all of the elements that are in the original set. Well, 10 is in the original set. It's the only element there. So since it's a set, it's not an element, it is a subset of set A. So be careful when you look at these things, okay? Going to go through a couple more examples to help you to understand this idea. Looking here, I look initially and say, are there braces? There are not, so I'm looking to see if it is an element in this case. We look, it is in there, therefore B is an element of this set. We see it in there. I'm calling this true. Moving on to the second one, it says, is C with braces around it an element of this set? Well, you may look and go, well, I see C in that set, therefore it is definitely an element. But you don't see C with braces around it in that set. I will tell you, if there were like braces going around this C inside this set, yes, I would agree. It's an element of it. But the fact that those braces are not there in this case means that this is false. Be careful, this one's tricky. Moving on to the next one, you look at the symbol here, the symbol is subset. So we look, is this a subset? Well, if it's a subset, there will be braces, which there are, and each one of these two elements will be in our set over here. Well, I look, A and B are both in the set, and there are braces around it, so this must be a subset. I'm calling this true. Moving on to the next one. Is A, B, C, D, oh, you look right here, this is proper subset of A, B, C, D. Now, if you were with us last time, proper subset means that it's a subset, but they're not equal. Well, I look, this is clearly a subset of this over here, but they are equal to one another. Therefore, I can say they are subsets, but not proper subsets. This is false. Moving on to the next one. Is A with braces around it an element of this set right here? We see A with braces around it within the actual set, therefore it is an element. That's true. Very, very tricky going on to the next one. As we look at F, you may think, well, hold on now. D is definitely in that set, therefore it's got to be a subset of it. If I had made this element instead of subset, I would agree with you. And if there were braces around D indicating that it was a set, I would also agree that it's a subset. But there are not braces going around D at this point in time. They're just looking at it and saying, is this single element a subset? And elements can't be subsets, only sets can. Therefore, this is false. Last one, tricky one. As you look, you go, well, there's nothing there. Therefore, no, it's not a subset here. But it turns out the null set is a subset of everything, every set. Because it has braces, therefore it indicates that it's a set, and there's nothing there, therefore this nothing is certainly in this set. This is actually true. Be careful for that one. This is our end of our video about elements and subsets.